In mathematics, the slope or gradient of a line is a number that describes both the direction and the steepness of the line. Slope is often denoted by the letter m. The direction of a line is either increasing, decreasing, horizontal or vertical. A line is increasing if it goes up from left to right. The slope is positive, i.e., a line is decreasing if it goes down from left to right. The slope is negative, i.e., if a line is horizontal the slope is 0. This is a constant function. If a line is vertical the slope is undefined. The steepness, incline, or grade of a line is measured by the absolute value of the slope. A slope with a greater absolute value indicates a steeper line. Slope is calculated by finding the ratio of the vertical change to the horizontal change between two distinct points on a line. Sometimes the ratio is expressed as a quotient, giving the same number for every two distinct points on the same line. A line that is decreasing has a negative rise. The line may be practical, as set by a road surveyor, or in a diagram that models a road or a roof either as a description or as a plan. The rise of a road between 2 points is the difference between the altitude of the road at those 2 points, say y1 and y2, or in other words, the rise is equals delta y. For relatively short distances where the Earth's curvature may be neglected, the run is the difference in distance from a fixed point measured along a level horizontal line, or in other words, the run is equals delta x. Here the slope of the road between the 2 points is simply described as the ratio of the altitude change to the horizontal distance between any 2 points on the line. Through trigonometry, the grade m of a road is related to its angle of incline theta by the tangent function. Thus, a 45 degrees rising line has a slope of +1 and a 45 degrees falling line has a slope of -1. As a generalization of this practical description, the mathematics of differential calculus defines the slope of a curve at a point as the slope of the tangent line at that point. When the curve given by a series of points in a diagram or in a list of the coordinates of points, the slope may be calculated not at a point but between any 2 given points. When the curve is given as a continuous function, perhaps as an algebraic formula, then the differential calculus provides rules giving a formula for the slope of the curve at any point in the middle of the curve. This generalization of the concept of slope allows very complex constructions to be planned and built that go well beyond static structures that are either horizontals or verticals, but can change in time, move in curves, and change depending on the rate of change of other factors. Thereby, the simple idea of slope becomes one of the main bases of the modern world in terms of both technology and the built environment. Definition: the slope of a line in the plane containing the x and y axes is generally represented by the letter m, and is defined as the change in the y-coordinate divided by the corresponding change in the x-coordinate, between 2 distinct points on the line. This is described by the following equation. Given 2 points and the change in x from one to the other is x2 minus x1, while the change in y is y2 minus y1. Substituting both quantities into the above equation generates the formula. The formula fails for a vertical line, parallel to the y-axis, where the slope can be taken as infinite. So the slope of a vertical line is considered undefined. Examples: suppose a line runs through 2 points, P equals and Q equals. By dividing the difference in y-coordinates by the difference in x-coordinates, one can obtain the slope of the line. Since the slope is positive, the direction of the line is increasing. Since m less than 1, the incline is not very steep. As another example, consider a line which runs through the points n. Then, the slope of the line is since the slope is negative, the direction of the line is decreasing. Since m greater than 1, this decline is fairly steep. Algebra and geometry. If y is a linear function of x, then the coefficient of x is the slope of the line created by plotting the function. Therefore, if the equation of the line is given in the form, then m is the slope. This form of a line's equation is called the slope-intercept form, because b can be interpreted as the y-intercept of the line, that is, the y-coordinate where the line intersects the y-axis. If the slope m of a line and a point on the line are both known, then the equation of the line can be found using the point-slope formula. The slope of the line defined by the linear equation is: two lines are parallel if and only if their slopes are equal and they are not the same line, or if they both are vertical and therefore both have undefined slopes. Two lines are perpendicular if the product of their slopes is -1, or one has a slope of 0 and the other has an undefined slope. The angle θ between -90 degrees and 90 degrees that a line makes with the x-axis is related to the slope m as follows. And examples: for example, consider a line running through the points N. This line has a slope m of 1. Can then write the line's equation in point-slope form, or the angle θ between -90 degrees and 90 degrees that this line makes with the x-axis is considered the two lines y equals 3x plus 1 and y equals -3x2. Both lines have slope m equals -3. They are not the same line, so they are parallel lines. Consider the two lines y equals 3x plus 1 and y equals x 3 to 2. The slope of the first line is m1 equals -3. The slope of the second line is m2 equals 1/3. The product of these two slopes is -1. So these two lines are perpendicular. Slope of a road or railway. Main articles. Grade separation. There are two common ways to describe the steepness of a road or railroad. One is by the angle between 0 degrees and 90 degrees, and the other is by the slope in a percentage. See also steep grade railway and rack railway. The formulae for converting a slope given as a percentage into an angle in degrees and vice versa are, and where angle is in degrees and the trigonometric functions operate in degrees. For example, a slope of 100% or as an angle of 45 degrees. A third way is to give one unit of rise in say 10, 20, 50 or 100 horizontal units, e.g., 110, 120, 150 or 1 to 100. Note that 110 is steeper than 120. For example, steepness of 20% means 1 to 5 or an incline with angle 11.3 degrees. Slope warning sign in the Netherlands. Slope warning sign in Poland. A 1371-meter distance of a railroad with a slope. Czech Republic. Steam age railway gradient post indicating a slope in both directions at Mels railway station, United Kingdom. Calculus. The concept of a slope is central to differential calculus. For nonlinear functions, the rate of change varies along the curve. The derivative of the function at her point is the slope of the line tangent to the curve at the point, and is thus equal to the rate of change of the function at that point. If we let delta x and delta y be the distances between 2 points on a curve, then the slope given by the above definition is the slope of a secant line to the curve. For a line, the secant between any 2 points is the line itself, but this is not the case for any other type of curve. For example, the slope of the secant intersecting y equals x2 at n is 3. By moving the 2 points closer together so that delta y and delta x decrease, the secant line more closely approximates a tangent line to the curve, and as such the slope of the secant approaches that of the tangent. Using differential calculus, we can determine the limit, or the value that delta y, delta x approaches as delta y and delta x get closer to 0. It follows that this limit is the exact slope of the tangent. If y is dependent on x, then it is sufficient to take the limit where only delta x approaches 0. Therefore, the slope of the tangent is the limit of delta y, delta x is delta x approaches 0, or dy dx. We call this limit the derivative. Its value at her point on the function gives us the slope of the tangent at that point. For example, let y equals x2. A point on this function is. The derivative of this function is dy dx equals 2x. So the slope of the line tangent to y at is 2 equals -4. The equation of this tangent line is y4 smiley face, or y equals 4x4. Other generalizations. The concept of slope can be generalized to functions of more than one variable and is more often referred to as gradient.